Hi, my name is Kate. I'm a postdoctoral researcher at Yale University, and today I'm going to be presenting work titled Realizing the Promises of Algorithmic Recourse Through Reliability, Accessibility, and Fairness Principles. And this work was done in collaboration with Professor Neill from New York University. So I want to start off by talking about what algorithmic recourse is. So let's say that we have some type of algorithmic decision maker, and let's say that it's a binary classification model, and it's making consequential decisions, meaning that it's denying or granting access to some type of monetary resource or education, or and so on. So for those who are provided with the unfavorable decision, along with being provided with the unfavorable decision, they're also provided with some type of recommendation about how to change their circumstances to obtain the favorable decision in the future from the same model. But I think that algorithmic recourse is best explained using examples. So let's say that you have some individual, they walk into a bank and they apply for a loan. That bank is using some type of model to determine who's trustworthy of a loan or not. And the individual is essentially denied the loan. Along with being denied the loan, they're provided with this recommendation that they should reduce their credit utilization by X% and then reapply for the loan in the future. And if the individual does this, they will be granted the loan by this model that's being utilized in the bank. So algorithmic recourse has gotten a lot of attention recently, specifically because of the fact that when it's actually adopted in its optimal form, meaning that it's operating as intended, it helps to promote trust, meaning that there's some way for individuals to overcome their challenges, and it also helps to promote temporally extended agency, meaning that the actions that individuals take to get success in the future actually result in that success. So our research objectives were to look at systems that provide algorithmic recourse at large. We wanted to take inventory of both recommendation formulations that have been proposed previously in the literature, and also look at the underlying model that's determining who is being given favorable outcomes and who is being given unfavorable outcomes. And we essentially wanted to propose a set of principles that need to be upheld so that these systems actually promote trust and agency for individuals who interact with them. And then what we're going to do is we're going to go over a specific training method specifically for the algorithmic decision maker that ensures that these models uphold a subset of principles that we're going to talk about. So the first principle that we're going to talk about is that these systems need to be providing reliable recommendations, meaning that when individuals perform the recommendations that are provided by the system and they return to the same model, they should consistently be receiving the favorable outcome. And this has actually gotten a lot of attention in prior research on algorithmic recourse, but to briefly touch on this, a recommendation usually takes the form of a minimization problem. So it's an optimization problem where we're essentially trying to find a point that crosses a model's decision boundary within the favorable outcomes region. And then we're trying to provide an individual with that point to tell an individual, if you change your circumstances to look more like this point, you will be given the favorable outcome in the future. And the general evolution of the formulation of a recommendation has generally been that they have become both more parametric in nature and more constrained in terms of what a recommendation can actually entail. So for example, we don't want to be providing recommendations that an individual reduce their age and then reapply for a loan, change their zip code at birth, and so on. There's also other formulations around incorporating structural causal models to take into account that an individual's features might be causally related to each other when we're formulating these recommendations. So the general idea is that as these become more challenging optimization problems, the recommendations become more reliable. So they're more likely to result in the individual getting the favorable outcome if they actually execute on the recommendation. But with that said, oftentimes that means that generating these recommendations becomes quite computationally expensive. So what we're kind of seeing in general is that a lot of research is still relying on more simple formulations of recommendations, but part of what we're trying to argue in this research is that if one of the purposes of algorithmic recourse is to promote trust in these systems at large, we need to be adopting reliable recommendations because it works against trust to have recommendations that are unreliable. It would actually be better to just have a system that doesn't provide recommendations at all. So the second principle pertains to the accessibility of recommendations that are realistically implementable. So as we mentioned before, these more reliable recommendations tend to be more complex optimization problems. And when we pair that with certain models that are determining who gets favorable and unfavorable decisions, what we see happen is that a lot of individuals who are actually being provided with unfavorable decisions, so for example, they're being denied access to a loan, actually have no recommendation available to them. So there's no way for them to, hire their income, pay off some of the credit that they owe to get that loan in the future. And similarly, if the purpose of algorithmic recourse is to increase agency for individuals so that they can actually plan for success in the future, if the majority of individuals who are not being provided with the favorable outcome also don't have recommendations, this is not materially increasing agency. So the last principle that we propose is that systems that provide recourse must be fair with regards to consistent treatment regardless of race, gender, and other sensitive attributes. This is usually defined by protected class membership. So now that we've gone over the principles, the first principle is really around making sure that the formulation of a recommendation is reliable, but the second two principles around accessibility to recommendations and fairness of the system overall are things that we can actually train the models that are making decisions around who gets favorable outcomes and unfavorable outcomes to actually uphold. So we can optimize for these two principles, which is what we're going to talk about for the remainder of this presentation. So what we do is we propose a burden measurement. So every individual who's interacting with this system has some type of burden that represents how challenging it is for them to get the favorable outcome. So the idea that somebody is initially being provided with the favorable outcome means that they have no burden. If they're being denied the favorable outcome and they also have no recommendation, so for example, they're being denied a loan from a bank, there's no way for them to get that loan in the future, they have the maximum amount of burden. And then we also propose this excess burden measurement, which is essentially the positive difference in an individual's burden of getting the favorable outcome compared to the burden we estimate that individual would have if they were a member of an opposite sensitive subpopulation. So we use structural causal models to kind of estimate this excess burden measurement. And then we use the burden measurement and the excess burden measurement to form this loss function that can be minimized during training to specifically train algorithmic decision makers. And part of this loss function is focused on predictive accuracy, but the other components are also focused on increasing accessibility to recommendations and lowering the cost of the recommendations, and also around upholding this fairness principle that we talked about before. So in terms of an evaluation, so we trained different models specifically to minimize this loss function that we proposed in the previous slide, and then we have other baseline methods. These baseline methods are aimed at predictive accuracy. They're aimed at equalizing error rates across sensitive subpopulations. They also, some of them are trained to specifically optimize to equalize the cost of recommendations across sensitive subpopulations, which is a prior metric that's been proposed around fair algorithmic recourse. And we test our method in 3 different data settings. One is simulated and one pertains to credit lending and the other one pertains to education. And to just briefly go over some of these results. So what we see is that our method statistically significantly increases the rate at which people are provided with recommendations. We see that the mean cost of recommendations is lower. So this all pertains to this principle that these systems actually need to be providing high accessibility to recommendations. And in terms of fairness, we're seeing that the absolute difference in the availability of recommendations across sensitive subpopulations is minimized. So specifically meaning, for example, the rate at which women are not being provided with recommendations when they're denied a loan is around equal to the rate at which men are being provided recommendations when they are denied a loan. And then lastly, we're seeing that the absolute difference in the mean cost of recommendations across sensitive populations is subpopulations is minimized. And something important to note here is that one of our baseline methods is actually specifically optimized to minimize this metric, and our method is outperforming this baseline method. And part of what we're trying to express in this paper is that when you're actually adopting a more reliable definition of a recommendation, which is important. It's actually really important to think about all the various different types of behaviors that could happen in these systems and to actually optimize some type of multi-objective loss function to actually uphold these principles of accessibility and fairness, and that this is really important for systems that provide algorithmic recourse to actually result in increasing trust and agency for individuals who interact with them. So please take the time to read our paper, and thank you so much, and I'm open to comments and questions.
You're right on time. So any questions from the audience?
Thank you so much. That's very interesting. This is a clarification question. Like, I don't understand the excess burden definition because I don't know how to interpret the counterfactual.
Yeah, so the counterfactual is this idea that we're using structural causal models to perform this hard intervention on essentially protected class membership and then see how that affects essentially all of the other features of an individual. So we were using structural causal models that have been used in research before, or we were able to like simulate the data so we know that it's not a misspecified structural causal model. But I would recommend reading the paper because it kind of goes over how we do the counterfactuals. Yeah, a good question.
We have time for one more question.
Great talk. I just had a question about the fairness metric or the burden metric, sorry. How does this relate to existing metrics such as like effort or equal recourse, which I'm thinking kind of look at the same thing but from a different angle, I guess. Like so effort fairness looks at the effort that's needed to cross the decision boundary, whereas you're looking at the same thing from the angle of what's the burden. Like it's probably just different sides of the same coin. How does this relate to those metrics? And then second, about the first principle, whilst it makes sense logically, what about like the causal influence of the model that takes place on the population and which causes changes which might change the actual recommendation that they're expecting to at the beginning?
So around the kind of like effort measurement versus burden measurement, this is a great question. I think I would need to either look more at the literature on like these types of effort measurements to like say more than it's like an aesthetic choice of like how to actually discuss burden versus effort being kind of like complementary. I think this question around kind of what happens to the population as recommendations are being provided and then people, resources, people like it's essentially shifting like the underlying population distributions. And I think that that's a really good question. And I think one of the issues that happens in the algorithmic recourse space is that we actually don't have a lot of real data about what happens when you're providing people with recommendations, which makes it kind of challenging to even understand how often and who is actually being able to fulfill these recommendations and then what actually happens to the population distributions over time. But I think it's a really big concern. Like I think it's a really relevant point to the algorithmic recourse space.
Yeah, thank you so much for your excellent presentations.